Greetings from K.S.Rangasamy College of Technology, Tiruchengodu. Myself, U. Vivek, Assistant Professor, Department of Mechanical Engineering. So today I have take the subject Composite Materials for the module Performance. The composite materials we have tested in the various testing. For example, tensile test, compressive test, impact test in the ISON and choppy, and fatigue test and tribological test. So these are the testing we will do in the composite material. So we have to discuss the one by one. First, you can see the tensile test. A tensile test is also known as a tension test. Is probably the most fundamental type of mechanical test you can perform on the material. The tensile tests are simply relatively inexpensive and fully standardized. By pulling on the something, you will very quickly determine how the material will react to force being applied in the tension. As the material is being pulled, you will find the strength along with how much it will elongate. Why we are doing the tensile test or tension test? The tensile testing is continue to pull on the material until it's break. You will obtain a good complete tensile profile. The curve will result showing how it's reacted to the forces being applied. The point of the failure is much interest and it's physically called as ultimate strength in the UTM test. So this is the initial testing missions. So here the workpiece will be fitted in the jaw. We can continuously load will applied on the machine side. So what will be happen in the workpiece side? So I showed in the graphical view. So in the UTM machine test, we can do see the following points will be calculated in the curve. First point is the elastic limit, and the next point is the yield strength, and the third one is the ultimate tensile strength. This is the final one, and the last one is we can break the material. So these are the stress strain curve for the composite material for the following curves. In the UTM machine, we are using in the tensile test, the work specimen is ASTM D3039. Describe the standard method for tensile testing polymer matrix composites. It's cover the test method for wide range of specimen dimension as well as many different testing configuration. In the application, we tested the carbon fiber specimen. The specimens are prepared to tap and they allowed the screw grip and the specimen. So we have to maintain the temperature of the tensile testing is 85 degrees Celsius and the low air is 60 degrees Celsius. So this is the tensile test workpiece position. Next we can calculate the fatigue testing. So fatigue testing is also one of the most important testing in the composite material. The definition of the fatigue test is can be through as a simply apply the cyclic loading to your test specimen to understand how it will perform under the similar condition in actual use. The load application is either be repeated application of the fixed load or simulation or insertive load. The load application may be repeated in the million times of load. So basically in the fatigue load testing is cyclically the load will be applied in the particular point of intervals. The load or strain ratio is cover the entire range of from the tension to compression. So I show the image for the better understand the axial loading. The small gauge is length. This is the workpiece will be fitted in the two jaw. It's an anti-buckling guide, and in the bending is cyclically the load will apply. So what is will happen in the after the load applying condition? So this is the images for the fatigue testing. Next, in the two types of fatigue testing will be there. One is a low cycle fatigue, low cycle fatigue. Another one is a high cycle fatigue. It is a HCF. In the low cycle fatigue is describe the service environment of many critical and primarily metal components in the low frequency and large load. In LCF is a typically involved the large deformation thereby accumulating damage on the specimen. And high cyclic fatigue is mostly using in the it is a typical in the aircraft gases, turbine engine and led premature failure and major engine components of the fans, compressor, turbine. This is for the HCF. So this is the drive motor will be initially load will come from the driving side. This is a supporting one. This is the tension is in the one side. Another one side is the compression. This is for the test specimen. So the reason is the cyclically load will be applied on the specimen. Next one is important of the composite material testing. This is the impact testing. This is the suddenly will be load will be applied on the workpiece in the V notch side. So what is the happen in the material? So this is the standard you are using in the ASTM. This ASTM D256 method will be used. This test is all can identify the whether to declining the temperature a brittle ductile transition occur in the polymer composite by using the this method. So this is in two category of impact testing. One is the choppy V notch method. Another one is the IZOD method. So choppy method means in example we can study for the various types of beam, cantilever beam and simply supported beam. In the choppy method, we are using the simply supported beam. The simply supported beam means both end are free. So that method concept will be followed in the choppy method. In IZOD method is cantilever beam. One end is fixed, another end is free. So the V notch will be fixed in the downside of the jaw. The load will be applied from the top of the material. So this is for the impact testing in two things, choppy and IZOD. The compression molded or machined test specimen in dimensions vary depending upon the particle test protocol. We can't do simply the pendulum will come hit from the material will be broken from the side. So this is for the load will be calculated in the digital meter of the impact testing. The olden days we are using the analog meter. Now it's the impact testing will be come from the reading will come from the digital meter. Next one method is a compression testing. It is similar for the tensile testing. In tensile testing is a pulling load will be continuously applied. In the compression side is pushing load will be continuously applied in the machine. Here also using the UTM universal testing machine. The composite compression testing method is provided a means of introducing a compression load into material while preventing from the buckling. Compression tests are preferred for composite material that are formed of relatively thin and flat rectangular test specimens such as a laminate panel. So the force will be applied in the top of the side, pushing force. In intermediate of the two jaw, we got to fix the composite specimen. This is an inclined fiber with the half axial angle. So here using the compression test in ASTM category, ASTM D3410. So that standard will be followed in the compression test. And another one is the ASTM D6641 also using in the ASTM standard of the specimen. Next, what are the major defects in the composite material? We have two various types of defects in the side. Example for the first one is a broken fiber. Fiber may be damaged. That means the broken fiber is a delamination. It is a nothing good bonding within the resin and the fiber. This is and the next one is a debonding of the resin side and a matrix crack. With properly not using the good matrix, that's a crack will be definitely will followed. Next one is a wrinkle and a resin rich and a foreign object, unwanted object will be inside from the fiber with the matrix inside. And the next one is the voids will be come from the inside intermediate of the specimen and porosity. So these are the major defects affected in the composite material. These defects is referred to the uneven distribution or clustering of hardening agent within the composite material. This can lead to areas that are either over curved or under curved. The failure mode can be localized, described in the mechanical properties of the composites. So these are the major defects in the composite material, and corrective measures of include the ensuring the proper mixing of the resin and hardener and using the control using the curing process. Next one is the damage tolerance. So we can analyzing the composite material. So we are using the answers of the for the calculate for the damage analysis. We can continuously load. We can apply it. The first one curve from the fracture toughness and material property, failure load. These are all things will be considered of the damage tolerance of the composites. And the next one is for the tolerable risk and inspection time with based on the time in the surfaces. So these are the three stages will be for come from the damage tolerance stage. The stage one is matrix cracking, second stage is delamination and interfacial debonding, and finally the stage is fiber breaking. So this is the damage tolerance on a curve for the composite material. Next, various environmental effect in the fiber reinforced polymetric composites. Majorly, we can seven thing will be considered: length of the fiber, orientation of the fiber, shape of the fiber, distribution of the fiber in matrix material, properties of the fibers, properties of the matrix material, and the proportion of the fiber and the matrix material. So these are the major factor considered. The factor influencing the performance of natural fiber reinforced composites. First one is the interfacial adhesive. Second is the effect on the fiber orientation, effect of the volume fraction, and the chemical composition of the fiber. So this is the majorly factor influencing for the natural fiber reinforced composites. Thanks for watching video. Keep learning and growing. Thank you.